Controlling technology, or predicting how it will change, requires a measurement of that change. Usually it can be done by measuring rates, such as speed. But there are other cases where normal rates do not apply, where the type of change requires a different kind of measurement. This is where time constants are used to calculate these types of changes. If an object moves at a constant speed of 55 miles per hour, you can safely predict that in 1 hour it will cover 55 miles, in 2 hours 110 miles, and so on. If a pump moves a fluid at a constant flow rate of 10 gallons per minute, you can safely predict that in 5 minutes 50 gallons will move. A steady electric current of 10 amps will move 10 coulombs of charge every second. And if heat flows through a radiator at a constant rate of 500 calories per minute, you can safely predict that in 2 minutes, 1,000 calories of heat will flow through it. We have already seen these cases in our unit on rate, but notice how we've said constant speed, constant flow rate, steady current, and steady heat flow rate. These conditions are uniform. The force that causes an object to change its position, the pressure causing a fluid to flow, the voltage causing the electric charge to flow, and the temperature difference causing the heat to move are all constant. So the amount of change that's happening over a period of time is uniform or in a steady state. Exponential changes are a tricky concept, but if you can represent them graphically, then draw the curve, find the time constant, you can accurately predict when those changes will be mostly complete. Huh? Thanks, Larry. Tank. Time constants are used to calculate and predict how long these non-uniform changes will take to be complete. Let's start with mechanical systems. A constant rate, such as speed, is uniform and will produce a straight line on a graph. A vehicle traveling at 100 kilometers per hour will cover 100 kilometers in the first hour, 202, 303, and so on in a linear way. This vehicle would cover 2,400 kilometers in a 24-hour day. A variable rate of motion, such as a vehicle that triples its speed every hour, is non-uniform and produces an exponential curve on a graph. Starting at 100 kilometers an hour, it would be on its way to a universal speed record. In the first hour, it would cover 100 kilometers, the second hour 300, the third 900, and so on, so it would cover 8,000 kilometers in less than 5 hours. In 24 hours, it would cover 850 billion kilometers. That's quite a vehicle. It would have to travel faster than the speed of light to do that. This is a non-uniform exponential change in speed. When the change is represented by an exponential curve, the curve becomes a tool that enables you to find the time constant in that system and predict how long it will take for the change to be completed.